Okay, thank you. Well done to inviting me here today in order to proceed with our lesson of mathematics, particularly in the topic which we call it calculus. But before proceeding, let me provide thanks to God who provide energy for me in order to exhaust what I have to my learners. Not only but also welcome my learners from Uganda, welcome my learners from Tanzania, welcome my learners from Kenya and other learners around the world who follow my lessons, but also much greetings to my learners who participating in the face-to-face in my classroom. So you are warmly welcome to proceed with this lesson of calculus, particularly in the part which you call it differentiation by chain rule. But apart from that, today we are much concentrate in the part which called differentiation by using chain rule methods. So let us see how it is. But in order to be able to deal with the operation of mathematics as a part of calculus, and that mathematics deal in the based on the differentiation by chain rule, you are supposed to know that if you have been given the complex function to differentiate, reduce them to the form that resembles any standard functions by means of algebraic substitution before, in order the function to be easy to be differentiated by chain rule, which can be given by dy over dx is equal to dy over dt times dt over dx. That is how it is. So let us see how it is. So if you have been given a complex function, differentiation by chain rule, if you have given complex function to differentiate reduce them means of algebraic substitution. Apart from that, algebraic substitutions in order the function to be is in order the function to be is differentiating by chain rule. Which given below as dy over dx is equal to dy over dt times dt over dx. This is how, this is the chain rule methods, quality chain rule. So after ending that example, we can deal with it very easily to see how it is. So up here, let us start to deal with the one among the examples in which that example can emphasize or can give us the simple way on how to deal with mathematical operation based on calculus, particularly in the part of differentiation by chain rule. So let us dig in to see how chain rule, let us dig in to see how we can operate the chain rule until to get the result or to get its derivative. So let us dig in to see how it is. So let us see example number 1. So here, let us see the example, how example number 1 is. Example number 1. Example number 1 requires to differentiate y is equal to, so differentiate y is equal to cos bracket 2x plus 1 with respect to x, with respect to x. If it's with respect to x, let us see how we can deal with it. If it is with respect to x, let us see how let us dig in to see how it is. So solution. Here we're supposed to know our function. Our function is that y is equal to cos bracket 2x plus 1. This is our function. If this is our function, we are supposed to let t is equal to 2x plus 1. If t is equal to 2x plus 1, function y is equal to cos t. Y is equal to cos t. So after that, let us differentiate to see how it is. Let us find out for t. As normal, we differentiate dy over dx is equal to dt over dx. Here is what we are finding for. In which here we are required to substitute the value of t in that equations. So dy over dx is equal to dt d over dx. We are open bracket. After open bracket, we are supposed to trace the value of t, which is equal to 2x plus 1. As normal, we are proceeding with the differentiation here. So dy over dx, we have d over dx bracket 2x plus d over dx plus 1. While any number power 0 is equal to 1. So differentiate any number power 0 is equal to 1. So here we will end up with dy over dx is equal to 1 times 2x power 1 minus 1 plus 0, in which any number power 0 is equal to 1. So if any number power 0 is equal to 1, so here we'll end up with a dy over dx is equal to 2x power 0 plus 0. With that, you will see how it is. So dy over dx here is equal to 2. If any number power 0 is equal to 1, you will multiply by 1. So dy over dx is equal to 2. So y is equal so t is equal to 2. If t is equal to 2, let us find for y. As normal here, we are finding or we differentiate y. So dy over dx is equal to dy over dx is equal to dy over dt is equal to dy over dt. Here we need to differentiate here we need to differentiate y. So let us proceed. Here is for y. So dy over dx is equal to d over dt bracket. We are supposed to substitute this value. So y to become here it is cos t. This is the value of what? This is the value of y. So dy over dx is equal to, when you differentiate cos, we are going to get negative sign. So here we get negative sine t. That's what we are getting. So y here is equal to negative sine t. If it's equal to negative sine t, let us see how it is to recall back in our formula now. So when we call in our formula, this tells us that if it's dy over dx is equal to dy over dt times dt over dx, this we are calling as our chain rule. This is a chain rule. If it is a chain rule, we are supposed to dig it slowly or step by step until to see how it is. So here, let us recall it. So dy over dx here is equal to y times t, which y times t is equal to y times you have y times t, or dy over dt over dt over or dy over dt times dt over dx. So here what we are doing is that here we are here the value of y, here the value of what? The value of t. So let us see place there. So y times t is that way. So here we have negative sign, negative sine t times 2 together, in which this it become dy over dx is equal to negative sine t times 2, which this value can be turned back here. So it can be turned back here to be dy dy over dx is equal to negative 2 sine t. But remember that this formula it's supposed to be identified. So this formula, but remember that the value of t will be placed there. I have placed there the value of t is this one. So let us proceed. So dy so here, but t, the value of t is equal to 2x plus 1. That's the value of t. So let us proceed to see how it is. So dy over dx is equal to negative 2 sine t. So dy over dx here is equal to negative 2 sine, the value of t is 2x plus 1. So the derivative of differentiation by chain rule using y is equal to cos bracket 2x plus 1 with respect to x. Let us see how it is. So dy over dx is equal to negative 2 sine bracket 2x plus 1. So this is the value of how to differentiate by using chain rule. So when you differentiate y is equal to cos 2x plus 1 with respect to x, you end up with this result. And this is how to deal with differentiation by chain rule, step by step, and that is what we are doing here. So that was the example number 1. Let us proceed with the example number 2 in order to provide the more emphasis on how to deal with it, and to emphasize on how for yourself to see how it become easy to differentiate by using chain rule in terms of calculus. So let us see how it is. Example number 2. So let us see example number 2. Differentiate y is equal to sine 4 x with respect to x. So let us see as normal how to deal with it in order to get the result. So let us proceed. So our function y is equal to sine 4x. After identifying that our function y is equal to sine 4x, let us to proceed in which this is the same as to write fx, in which that fx is equal to f dash of x, in which this f dash of x is equal to dy over dx. So let us see how it is. So let's proceed. See how it is. We are supposed to let. So let y let t is equal to 4x. Let t is equal to 4x. So if t is equal to 4x, so our y become y is equal to function y. So the function y become y is equal to sine t. So let us to see how it is. So let us differentiate for t. dy over dx here, it indicates that it is equal to dt over dx. Dt over dx. Let's proceed to see how it is. So dy over dx is equal to d over dx bracket. We are trying to open bracket to see how it is. When open the bracket here, we get 4x. So our task here for t is to differentiate t over dt over x. So dy over dx is equal to 1 times 4 x power 1 minus 1. So when proceeding here, dy over dx is equal to 4x power 0. Why it become power 0? It become power 0 after taking 1 minus 1 equal to 0. So it become 4x power 0. But remember that any number power 0 is equal to 1. If any number power 0 is equal to 1, yet dy over dx is equal to 4 times 1. If it's equal to 4 times 1, so dy over dx here is equal to 4. Is equal to 4. So here, t is equal to 4. After knowing that t is equal to 4, let us proceed to see how it is. Let us differentiate or finding the derivative of y as normal. So this is for y. This is for y. So if for y, let us proceed. So dy over dx is equal to dy over dt. Let us find or let us differentiate that in order to get the value of t, in which that the value of to get the value of y, in which that value of y, we are going to utilize it when you find out the value or the differentiation here. So dy over dx is equal to d over dt. We are open the bracket. The value of t here, the value of y here is the value of y is this one. So here we differentiate sin t. We differentiate the sin t here. You will see how it is. Let us see how it is. So dy over dx here is equal. When you differentiate sine, you get cos. So it become cos t. After knowing that, this implies that, or this tells us that the cos t is the value of y after differentiation. So y is equal to cos t. If it's cos t, here we are supposed to recalling our chain rule. So let's just see how it is. So here we say that you recall chain rule. Call chain rule. If we call chain rule, if you get chain rule is dy over dx is equal to dy over dt times dt over dx. If it's that, this is the rule which you call it chain rule, in which we are going to use it in order to emphasize or to provide more emphasis on how to deal with the mathematical operations. So let us proceed with this formula. So dy over dx is equal to dy over dt times dt over dx. This tells us that this is the value of y, this is the value of t. So here what we are doing is the y times t. What we are doing here is y times t. If it's y times t, let us see how it is. So dy over dx is equal to dy over dt times dt over dx. If that is what we are going to do, let us see how it is. So dy over dx here is equal to y, the value of y is cos t, is cos t times the value of t, which is equal to 4. If is that, we are supposed to recall that we have the value of t, but before looking at the value of t, let us rearrange this one. This one is just like write dy over dx is equal to 4 cos t. But as I have been told that the value of t we have, the value of t is which one we have been writing there. So let us see how it is. So dy over dx here is equal to 4 cos t, but t is equal to 4x. If t is equal to 4x, we are supposed to substitute this value of t into the formula here. So dy over dx is equal to 4 cos t. If it is 4 cos t, here we substitute that value. So dy over dx is equal to 4 cos, we are placing the value of t, which is equal to 4x. So dy over dx is equal to 4 cos 4x, and this is the result or the product. This is the value of differentiating the y is equal to sine 4x. So when you differentiate y is equal to sine 4x, the result which we are ending up with it is dy over dx is equal to 4 cos 4x. So everyone or every my students who follow me or keep in touch with me from the beginning up to the last, I think he or she have been understood how to deal with the mathematical operation, particularly based in the calculus by using the method of differentiating mathematical operation by using chain rule. So how chain rule work? But this is how chain rule work on mathematical operations. So up to here, let me say thanks my learners from Uganda, thanks my learners from Tanzania, thanks my learners from Kenya, thanks also my learners around the world who follow my lesson. But much great things have been provided to my learners who participating in this face-to-face lesson today. Don't plan to miss the next lesson, because you have don't plan to meet the next lesson because we are preparing good news for you. So don't plan to miss. Up to here, let me say thanks for listening. See you later. Enjoy mathematics. Thank you, well done, for inviting me here to proceed with your lesson of mathematics, particularly in the topic which you call it calculus. But today we will concentrate on the differentiation by using the product rule. But before proceeding, let me provide thanks to God who provided energy for me to exist here in order to provide or to exhaust what I have to my learners. But also, welcome my learners from Uganda, welcome my learners from Tanzania, welcome my learners from Kenya, as well as welcome my learners around the world who follow my lessons, particularly for those who are participating in my lesson either in virtual or in real life situation in my classroom. But today we are much concentrated on the part of calculus, particularly to differentiate the mathematical operations by using the product rule. If we need to deal with the method of dealing with mathematics, especially in calculus, particularly in the part which you call it differentiation by using the product rule, we are revealing that, or we are supposed to know that u and v are the functions of x and y is defined as the product, or defined by the product of two functions, which is y is equal to u times v. Mean that this defined as that one, u is equal this defined as that y is equal to u times v, and the derivative of function y with respect to x is defined or given by the formula u dv over dx plus v du over dx. Where product term, the product is that you are supposed to multiply the function v times the product after differentiation, which here is du over dx. So here we are supposed to multiply v times du over dx, and here we are supposed to multiply v times du over dx, and here we are supposed to multiply u times dv over dx. That's why we are saying that is the product. If it's a product, we are supposed to do something which is very, very important for us. So dy over dx or f dash of x here defined as u dv over dx plus v du over dx. So this is the formula in which we are going to use when we are dealing with the differentiation as a part of differentiation methods, which that differentiation is a part of calculus. Which calculus is very important for us in our everyday life situation in the scientific career and engineering. So let us see example on how to deal with the operation or mathematical operation by using the product rule as a method of differentiation as a part of calculus. So let us begin to see how it is. Let us see example number 1. Example number 1, determine the derivative of y is equal. Example number 1. Determine the derivative of y is equal to x cos x. Here we are supposed to find the derivative, or find out the product, or find out the result or outcome by using the operation, or by using mathematical operation, by using the product rule as a part of calculus. So let us begin to see how it is. So here we are supposed to know that our function is y is equal to x cos x. So here let us know that y is equal to x cos x. After knowing that, here we are supposed to know that after knowing that, here we are supposed to know that we are supposed to let. So here we are required to let. So let u is equal to x and v is equal to cos x. From here we are supposed here then differentiate u and v. So yeah, we are supposed to differentiate both in order to see how its property is. So let us start for u. Let us here start from u. When we talk about u here, mean that dy over dx is equal to du over dx. That is what we are starting to do. So if you need to do so, mean that the u, we are supposed to substitute the value of u, which we have been writing here in the questions. So dy over dx is equal to d over dx, bracket, open the bracket, then you fill over substitute the value of y, which is the value of y in this one. So you are supposed to place x there. Then we are required to proceed very well. So after here, let us see how it is. So dy over dx is equal to 1 times x power 1 minus 1. So let us go. So dy over dx is equal to 1 times x power 0. 1 minus 1 is equal to 0. So here it is 0. So here, but remember that any number power 0 is equal to 1. So dy over dx is equal to 1 times 1. So dy over dx is equal to 1, in which this is the product or the result of differentiating u. When you differentiate u, you are going to get 1. So here this is u. So u is equal to 1. After knowing that u is equal to 1, let us differentiate the v in order to get the value of v. So here we are considering the differentiation of v. So here we are dealing with for v. So if it's for v, dy over dx is equal to dv over dx. So here we are supposed to substitute the value of v in which we have been writing there. So here dy over dx is equal to d over dx. We are open the bracket, then we are substituting the value of y. If the value of y is cos x. So here we are substituting cos x. After substituting the cos x here, we are now ready to deal with it in order to get the answer. So let's see here, dy over dx is equal, when you differentiate the cos x, you are ending up with a negative sign x. So when you differentiate cos x, you are ending up with a sign x. So let us see. So here we will remain with the negative sign x. So dy over dx is equal to negative sine x. It's negative sine x. This is the value. This is the value for v. And if it's the value for v, let us place v here is equal to negative sine x. After knowing that, or after getting that result, here we are supposed to find out or to trace back or to return back in our product rule formula in order to substitute this value in the formula. So here we are talking that recall dy over dx is equal to u dv over dx plus v du over dx. This is our formula which we are going to deal with it. So here we are supposed to be very carefully to deal with it. So we require to know that dy over dx is equal to d. We are supposed to place the value of d, of u, and the value of v, then we multiply with its value here. So the value of u here is x, so it becomes x times dv over dx plus the value of v is equal to cos x times du over dx. Then we are waiting for its value. So after doing that, here we are supposed to remember that dy over dx is equal to x times the value of dv over dx. Here it's negative sine x plus cos x plus cos x. The value of du over dv is equal the value of du over dx is equal to 1. If it's like that, let us proceed. So dy over dx is equal to negative x sine x plus cos x plus cos x. Why plus cos x? This one times this 1 times cos x is equal to cos x. So therefore dy over dx is equal to negative x sine x plus cos x. This is the value of differentiating the function which is called y is equal to x sine. This is the value of differentiation by using the product rule, by using the value of or function of y is equal to x cos x. So that is how to deal with that is how to deal with the calculus, particularly by using the product rule in order to deal with the mathematical operations for the purpose of understanding what we are doing. After knowing that, let us see another example. Up here, let us proceed with another example which will be helpful for us in order to deal with the mathematical operation by using the product rule. So let us see how it is. Example number 2. Example number 2 here. So example number 2 here, we are required to differentiate y is equal to x is equal to 3x power 2 cos 2x. So let us dig in to see how it is. So our function y is equal to 3x power 2 cos 2x. Cos 2x here we are supposed to let. So let u is equal to 3x power 2 while v is equal to cos 2x. Then differentiate u and v. So you're supposed to do so. Let it, then differentiate. So let us start with u to differentiate u. So here let us for u dy over dx is equal to du over dx. That is what we are doing. With du over dx, let us say how to do. So dy over dx is equal to d over dx. Open the bracket. After opening the bracket, we are supposed to add the value or to substitute the value of u, which we have been right here. So we are supposed to add the value of u. So the value of u here is 3x power 2. So that is what we are starting to differentiate. So dy over dx is equal to 2 times 3x power 2 minus 1. This is what we are doing. But after doing that, here let us proceed. So dy over dx is equal 3 times 2 is equal to 6. So here it becomes 6, but here it becomes 6 power times x. 2 minus 1 is equal to 1. So it's equal to 6x power 1. But x power 1 is equal to the same. So dy over dx is equal to 6x. This is the value for u. And if this is the value for u, so here u is equal to 6x. After knowing that, let us proceed with the value of v. Let us see the value of v. Differentiate v. So here let us deal with the part of v. So for v, let us see how we can deal with the operation mathematical for v. So v means that dy over dx is equal to dv over dx. If we do that, let us see how it is. So dy over dx is equal to d over dx. Here we need to substitute the value of u, which you have been left. So the value of u here is cos 2x. That's the value which you are supposed to substitute there. So dy over dx here is equal to, when you differentiate the cos, you will end up with a negative sign. So here we will end up with a negative 2. So here we will end up with a negative sine 2x. So here we got a negative sine 2x. When we get the negative sign, if we can be getting negative sine 2x, let's proceed to see how it is. So this is the value for v. If it's value for v, so v here is equal to negative sine 2x. After getting this value, let us recall to the product rules in which we are going to use in order to get that answer. So here we're going into the product rules. Let's recall dy over dx is equal to u dv over dx plus v du over dx. So So we are supposed to proceed. So dy over dx is equal. We are supposed to place the value of u and the value of v. Then we are multiplying with its differentiation or its derivatives in order to get the product rule. In order to find out the product. So v here is equal to 3x power 2. This is the value of u times dv over dx plus v, the value of v is cos 2x times the value of u is equal to du over dx. After knowing that, let us proceed in order to see how it is, or how it is very simple, or how to get that product. So dy over dx is equal to 3x power 2. We are substitute the value of v. The value of v is negative sine 2x. So times negative sine 2x bracket plus cos 2x, which multiplied by the value of u, which is equal to 6x. So we are proceeding until to wind up our mathematical operations. So dy over dx is equal to 3x. But this thing, so dy over dx here is equal to negative 3x power 2 sine 2x plus 6x cos 2x. So the value a will differentiate the function y is equal to 3x power 2 cos 2x in terms of using the differentiation as a part of calculus by using the product rule. Here the result becomes, so the differentiation is equal to show that dy over dx is equal to negative 3x power 2 sine 2x plus 6x cos 2x. This is the result of how to differentiate by using the product rule of differentiation as a part of calculus. So I think everyone, he or she, have seen what you have been done, and this is the simple way on how to deal with the mathematical operation based on the calculus, particularly by the method of product rule. So up to here, I think everyone, he or she, understood well what we are doing or what you have been done by using the mathematical operation, of calculus, particularly by using the product rule as a method of differentiating or doing the mathematical operation in which that mathematical operation based on the calculus. So up to here, let me say thank you, my learners from Uganda. Thank you, my learners from Tanzania. Thank you, my learners from Kenya. Thank you, my learners around the world who follow my lessons, particularly in the part of calculus. You're warmly welcome, and we have been planning to prepare good things for you, so don't plan to miss the next lesson, in which the next lesson will be more interested than what you have been done here today. So I think everyone, he or she, understood what you have been done here, and I think if you have been following step by step in the terms of product rule as a part of calculus, I think everyone, he or she, have been understood what we have been done here for the purpose of well understood for everyone to deal with the mathematical operation, particularly in the part of calculus, in the method of differentiation, particulars in the differentiation, particularly in the method of product rule.